Hello and welcome to my channel. Let's solve this Cambridge paper 1. The first question says, water drips from a tap into a measuring cylinder. The table shows the volume of water in the cylinder every minute for 4 minutes. What's the average volume of water collected in the cylinder each minute? So how many minutes do we have? 4 minutes. What's the final volume that we have in the cylinder? It's 112. So what's the average? That would be 112 centimeter cube divided by 4, which is 28 centimeter cube. Okay, question 2. The graph shows how the speed of an object changes with time. Speed versus time. How far does the object travel in 10 seconds? Now, whenever we are given a speed time plot, to find the distance, what do? We find the area under the curve. So we got to find this area. Now what we do is we could break this into two parts. We have a triangle and a rectangle. This is at the center, so this would be 5. So what's the area? Well, the area of this guy would be, this distance is 5 and this much is 8. 5 times 8 is 40. What about this triangle? That would be 1/2. The base is 5. The altitude is 8. That's 4. That's 20. So we have 40 and 20. That gives us 60. Okay. 3. Which expression can be used to determine the acceleration of free fall of an object? Okay. Free fall. Now we are looking for the acceleration. Okay. If you remember, F equals ma, and you rearrange, you get A equals F over m, correct? So the acceleration should be force over mass. Do you see any force? No force here, no force. Yes, force, but divided by area. No. That's not correct. What about this? Weight. Weight is a force divided by mass. That's right. So that's the correct option. What's not a possible unit of density? What's density? Yeah, it's mass over volume. Okay, so we need to have mass at the top, volume at the bottom. Mass at the top, volume at the bottom, correct. Mass, volume, correct. Newton? No, that's wrong. So we'll choose C and move on to the 5th one. The diagram shows an extension load graph of a spring. Load is on the horizontal, extension on the vertical. You kind of pull the string, right? Okay. An empty can of weight 3 Newton is suspended from the spring. Liquid is poured into the can until the extension is 8 centimeter. What is the weight of the liquid? The extension is 8 centimeter. Now, corresponding to 8 centimeter, what's our force? The force is 16 newtons. Okay. Out of those 16 newtons, 3 newtons is contributed by the can. So how much is left? 13. So 13 is the correct option. Does that make sense? A wooden bar is pivoted at its center so it can rotate freely. 2 equal forces are applied to the bar in which diagram is the turning effect greatest. Now, the turning effect, which is also known as the moment of a force, depends on what? It depends on force and how far you apply the force. F times R. Okay, now you can't change the force. It's F and F everywhere. But we can vary the distance. And it's maximized here. This guy tries to rotate it. This guy also tries to rotate it the same way. Okay. Why is this a bad choice? This is a bad choice because this one only uses half of the distance, while these guys use the full available moment arm, R and R. Okay, this is terrible. This won't rotate. This one tries to rotate it this way, and this force tries to rotate it the other way. So they're going to cancel. Bad idea. Okay, these guys are similar. So you're going to go with part A is the correct option. The lower its dash of gravity, the greater the dash of an object. The lower the center of gravity, the greater the stability. If you have a really tall guy, okay, Michael Jordan, and if you push him, he's going to tip over and fall. On the other hand, if you look at a weightlifter, okay, an Olympic weightlifter who is short and stocky, and if you push him, he won't be happy. Neither would he tip over, right? It's because his center of gravity is lower to the ground. This guy has a center of gravity which is high above the ground. You push it, it's going to tip over. That's why cars, which are like really tall cars, okay, let's say this is a car. It looks like a horrible car. It's a tall car. If you push it, it can topple. Okay, if you have a double-decker bus, it's easier to topple over. The same reasoning. Make sense? Which process involves the transfer of energy by mechanical working? So you need to have a mechanical work. You need to apply force, and that force should move something. That's mechanical work. And the answer should be this: pushing a box along the floor. You apply a force, the force makes the object move. That's mechanical work. Okay? Which quantity is calculated from the product of force and the distance moved in the direction of force? Yeah? What's the answer? The same thing, mechanical work. Which physical quantity has the unit Newton per meter square? Newton is a unit of what? Force. Meter square is a unit of what? Area. What's force over area? Pressure. Good. The three states of matter are solid, liquid, and gas. Which list shows three distinguishing properties of most liquids? Well, what's a property that a liquid has? It's able to flow. So we'll go with C and D. No fixed shape. Yeah, that's it. No fixed shape, but it has fixed volume. It's very difficult to squeeze a liquid. The particles of a substance in a particular state of matter move freely with random motion. The average speed of the particles is increasing. What is being described? Okay. First of all, they move freely. So can it be a solid? No. The particles of a solid, they are rigidly locked in a lattice. So it can't be a solid. So it's either, and they move freely. So should be a liquid or a gas. It should be a gas, right? So if it's a gas, because the particles of gas, they move freely. But what's happening to it? The average speed is increasing. You can make the particles move faster if you heat the gas. Easy peasy. A substance melts at minus 40 degrees Celsius. What is its melting point in Kelvin? So you simply need to convert Celsius into Kelvin. How do we do that? Negative 40 plus 273. How much is that? Well, you can do that, right? Okay. A solid substance is heated from room temperature. The graph shows how the temperature of the substance changes with time as it's heated constantly. At which time has the substance just become completely liquid? So we start with a solid, right? So this is a solid here. And what's this thing describing? Its temperature is increasing. So the solid is getting hotter and hotter until it melts. This is where it begins to melt. This is where it has completely melted and now it's liquid. So this is liquid. This is what are we asked? At which time has the substance just become completely liquid? C. Okay. What about D? What's D? It's starting to evaporate. Okay. Okay. A student writes sentences about evaporation, but there are two words missing. During evaporation, the dash energetic particles escape from the surface of a liquid. The most energetic particles, right? How come least energetic particles would leave? The guys that have the most energy, they're going to escape. Evaporation causes the temperature of the liquid to decrease, right? Evaporation causes cooling. Four samples of material with the same dimensions are tested. Which material gives the highest rate of thermal conduction? So we're looking at which one is the best conductor. Which one is the best conductor? Don't say plastic. Okay, that would be a very bad answer. It's copper. Copper is a great conductor. A metal pan contains cold water. When the pan is placed on a hot stove, the water gets hotter. By which process does the heat pass through the metal pan? Well, definitely conduction. Okay, conduction, when you have a pan and you put it on a flame, the atoms here, they gain energy, they begin to vibrate, and they pass the vibrations and the energy into the water. Okay, so we got conduction. But look at the question, the heat passes through the metal pan. So you just have to focus on the metal pan. You don't say, okay, now the water is heating, so there's convection in the water. That's separate. Just the metal pan. The metal pan can only conduct. Okay. Which row gives the correct description of a sound wave? Well, it does transfer energy without transferring matter. That's true for every kind of wave. Is it a longitudinal or a transverse? It's a longitudinal wave. Transverse goes up and down. Sound, as I speak, the particles of air, they vibrate back and forth. That's longitudinal. Okay, light from a torch is incident on a plane mirror. The angle of incidence is 38. What's the angle of reflection? This is easy. Angle of incidence is always equal to the angle of reflection. When converging lens causes parallel rays to converge. That's the focus. Which statement explains this? Well, what happens actually is a refraction, the bending of light. Okay, D. White light enters a prism and emerges separated into the 7 colors of a visible spectrum. What's this? It's dispersion. Okay. Which radiation has a lower frequency than green light? So if this is our spectrum, this is green, okay. The red has the largest wavelength. This has the smallest wavelength, but frequencies are opposite. So if red has the largest wavelength, it has the smallest frequency, and the frequency increases this way. So green, everything to the right of green has smaller frequency. Okay. But the options don't have other colors, so we got to go beyond this spectrum. This is infrared and this is ultraviolet. So infrared lies to the right of green light and therefore has a lower frequency. Okay, so infrared. Satellite phones can use 2 types of satellites. Geostationary satellites at a height of this, or fast-moving low-orbit satellites at a height of this. Why do geostationary phones have noticeable delays in conversation, but low-orbit satellite phones do not? What do you think? The answer is in the height. Geostationary satellites are at a larger height, so the waves have to travel a further distance and come back after traveling a longer distance. That's explained by D. 4 sound waves are shown on an oscilloscope. The axes have the same scales. Which graph represents the loudest sound with the lowest pitch? Loud is represented by how tall the wave is. So it has to be either A or D, but it needs low pitch. Low pitch means large wavelength. So this one has a large wavelength. Large wavelength means small frequency, which means low pitch. The north pole of a magnet is moved closer to each end of two different rods, X and Y. Both ends of X are attracted to the end pole. Only one end of Y is attracted to the north pole. Which statement is correct? So we have two rods, X and Y, and you bring a north pole. Both ends of X get attracted to the north pole. Now imagine this was a nail. Wouldn't that happen? This magnet would attract this end. It would also attract the other end. So X is what? X is an unmagnetized iron rod. Y has to be a magnet, because only one end, if this is south, it will be attracted to south. But if this is north, it's not going to be attracted to the north. So Y is magnetized. So the correct answer is, makes sense? A student shows that one charged plastic rod repels another charged plastic rod. Other students make the statements: both rods have gained electrons. Both rods have lost electrons. One rod has gained and one has lost. Which statements are possible explanation of what the student shows? Now, if you have a charged plastic rod and another charged plastic rod and they repel, okay, so they both have the same charge. Either both are negative or both are positive. Okay, so that can happen if both rods have gained electrons. That would make both of them negative. Or both of them lose electrons. That would make both of them positive. So 1 and 2. Okay, an electric current in copper wire is due to the flow of charges. What kind of charges flow in wires? Well, electrons flow in a wire. Okay, protons can't flow. We don't have copper nuclei is the same thing. If nuclei flows, protons will flow. That's not what happens. Okay, don't make that mistake. Which unit is equivalent to 1 volt? 1 volt. Yeah, voltage is energy over charge. Energy is joules, charge is coulomb. B. The potential difference across a resistor is 2 volts. What's the current? We'll use Ohm's law. V equals IR. That means I equals V over R. V is 2, R is 24. That's 1 over 12. How much is 1 over 12? There's a current of 5 ampere in a resistor. The potential difference is 24. How much energy is transferred in 1 minute? The equation for power is V times I. This gives you the energy used in a second. How many seconds do we have? 60 seconds. So the total energy would be V times I times 60. So we have 24 times 5 times 60, right? That's got to be a huge number. So the answer should be this. Which circuit contains a fuse, heater, and lamp? This has lamp, this has lamp, this has lamp. So D is incorrect. Heater and fuse. This guy has fuse. This guy doesn't have fuse. So B or C. Heater. So where do we have a heater? This is a heater, right? What's this? This is a variable resistor. So let's go with B. Similar circuits with an ammeter connected at 4 different points. In which circuit will the ammeter show the highest current reading? It has to be A. Why? Because all of this current which flows through the 2 branches flows back through the ammeter. In this case, How some of the current bypasses the ammeter, so it's going to show a smaller reading. Same thing here. Some of the current goes through this branch, bypassing the ammeter. That's not good. Same thing can be said for this. So the answer is A. The metal cases of electrical appliances are connected to an earth wire. Which statement is not correct? The live wire may become loose and touch the metal case. If the metal case becomes live, the earth wire conducts current to the ground. That's correct. The earth wire needs to have a high resistance. Why should an earth wire need a high resistance? So that's wrong. Which statement is correct? A transformer is used to step up the voltage so the current is transmitted more efficiently. Well, the transformer is used to step up voltage, but what we want to transfer is power. Power is what we care. We don't care about current. Power means the energy that's being delivered per second. So that's the correct statement. A transformer step up. A transformer is to step up the voltage, not the current. We step up the voltage so that the power is transmitted more efficiently. So C. Which particles are found in the nuclei of atoms? Protons? Yes. Neutrons? Yes. Electrons? No. Protons and neutrons only. Electrons reside in the outer shell. Which statement about radioactive decay by alpha, beta, and gamma is correct? The only type of radioactive decay that changes the nucleus of one element to that of the other element is alpha. Alpha decay does change a nucleus. That's true. Can beta decay change a nucleus? Yes, a beta decay can change a nucleus. Basically, what happens in a beta decay is a neutron converts itself into a proton and an electron. So there's an increase in the proton number. So if the atomic number increases, the type of nucleus changes into a different nuclei. So alpha and beta both can do that. So the correct option is B. A sample of a radioactive isotope has a mass of 100 grams. The half-life is 6 hours. Which graph shows the decay for this isotope? So in 6 hours, half of the thing is going to disappear. So that means in 6 hours, what should we get? We should have 50 grams. Okay, 50 grams. Furthermore, the decay is never a straight line. It's always a curved line. So we can right away remove these two guys. Let's focus on A and C. Right away, we see at 6 hours, the mass remaining is too low. It should be 50 grams. So it has to be C, but let's check. In 6 hours, yes, we have 50 grams remaining. This is the correct option. Which type of object orbits planets? Yeah, moon. Right, we have a moon. And that kind of goes around our Earth. What is the Milky Way? Where's chocolate? Right? Yeah. When I was a kid, I used to like a chocolate called Milky Bar. That was very expensive. And I was able to eat it only on special occasions such as Eid. So, okay, what's a Milky Way? It's a galaxy. Okay, real simple. That's it. Through this paper in, I think, maybe 20 minutes or less. Well, I'll see you in the next video. Okay. If you want more help and get better grades, I teach one-on-one. Send me a message and we can work together. And I'll get you closer to that perfect grade that you want. I'll see you in the next video. Take care. Happy learning.